Okay. Here to talk about the research effort done by Greta Franzini, who's also present here, and myself in training or better fine-tuning South Tyrolean Dialect-to-Standard German speech-to-text or speech-to-translation system, but starting with the resource that we reuse, which is AlpiLinK. So let me give you just some context to understand the issue here. So South Tyrolean dialect, it's like many dialects, a cluster, of varieties. In this case, we have Bavarian varieties, and it's spoken in a very small area in the north of Italy. And Standard German dominates the written communication. So in the area, let's say that the population mostly speaks and, let's say, does business in a dialect, but the official language which dominates the written landscape, it's Standard German, or at least the South Tyrolean version of Standard German. The bottleneck for ASR technology is that all the models that are trained on Standard German do have a hard time dealing with the dialect, and that creates some sort of linguistic gap between the speakers, the users of the language, and the current state of the technology. Recently, or like 2 years ago, to be precise, Verena Blanchke and colleagues did an interesting survey, which told us something interesting. Essentially, that shows that there is a strong demand for ASR technologies for dialect. And if you want to verify briefly, this is just an excerpt from the paper, and this is the table. Essentially, as you can see, for example, an instant input, something like Alexa, for example, or chatbot input are considered to be useful or rather useful, and speech-to-text to German, which is this line that you see here, is also considered pretty high up in this ranking. So that is, let's say, the original intent. So we wanted to work towards filling that gap, towards solving that problem, or at least trying to solve that problem. So we were lucky enough to find a rather large, well-organized data source, essentially, which is the AlpiLinK project, which was born originally to document all the languages, all the varieties, all the dialects, all the in their phonological, morphological, syntactical variations in the Alps, essentially. The project produced a lot of data. It had its own data collection application. It could be accessed via a mobile phone, for example. And one of the varieties that were documented and for which data were collected was South Tyrolean, which is what we used. Let's say the set of different tasks that the users of AlpiLinK went through is diverse. Sometimes they were asked to just name objects or translate words, but it were also asked to translate sentences from German or Italian into their own variety. And so we could access all those translations, maybe short excerpts, and use them in our fine-tuning effort. As I told you, like the data is quite substantial, and we didn't have to do much work to get the data. They were already there. 248 speakers and more or less close to 5 hours of translation audio. So the dialect variety on the spoken side, on the audio side, and the corresponding text in German. Of course, this is it's a very nice resource, but there is a couple of trade-offs. Strengths is that there is a lot of speakers. We have a lot of variety, and that helps when fine-tuning an ASR model. The weakness is we only have essentially 30 different prompts. So we only have 30 repeated over and over translations from many speakers. So that's one of the issues. So to extend a little bit the capability of this resource and to make it useful, we also decided to include other resources like the learner textbook, which is available through the Provincia di Bolzano website, for example. We also had some in-house recordings thanks to our effort and to our colleagues that essentially asked us to transcribe for them some text. We have promotional videos that we could collect thanks to the IDM collaboration, a collaboration with IDM, which is a local media company. And we also have a collaboration with the audiovisual archives of the provincia, which provided some extra hours. But all these essentially, all the last three resources were basically annotated automatically using the first fine-tuning effort. So we used AlpiLinK plus a couple of other things. AlpiLinK was capable of generating some meaningful transcription, or let's say useful transcription, and that helped us then extend that to include more data in our current training data set. So the base model that we use is OpenAI Whisper Large v3. These are a couple of technical details, but you can either read the paper. In the interest of time, I will skip through quickly. But we only fine-tune freezing the encoder. Essentially, we were not interested in learning more sounds, but we wanted to get translation out of it. We had to prepare all the acoustic inputs, so all the audio inputs had to be resampled and formatted in the right way. I'll skip that part, but you can ask me questions later if you want. And this is basically the results and evaluation. So the baseline, so Whisper, a vanilla version of Whisper, is not particularly great. As you can see here, it does only 46%, 44% blur, and has a pretty much high error rate. Just AlpiLinK plus a few extra resources brought us to this point where, it's not exactly incredible, but it's usable, or more usable than before. And by using this version of the model, we managed to annotate some of the data, which we also had to, of course, then hand check. And then we got finally to the point where we could land to a place where the model was actually useful, filling that gap I was talking about earlier. So small variety specific data outperforms large general corpora. In our case, it was true, and then we also had to make sure that we could transition from, let's say, well-redacted, well-put-together data sets to something a bit more spontaneous, because that is where the model is then used in the end. We continued our experiment after the publication of the paper. So again, briefly, AlpiLinK, this kind of short transcription created issues because they were too short for this kind of technology. So we concatenated them, essentially randomizing the sequences, and that improved the performance. And also we managed to train another model to see if there was a difference in performance, and we found out interesting things thanks to training the Canary model, which we are also currently using in an extra effort of forced alignment for the future. Lessons learned, so which is this most important part. I'm taking too much time. Automated audio verification. We found out that there was some noise, and some of the audio samples were not particularly useful because there was distortion. We ran an automated verification, and we could spot those faulty audios. We would recommend, and we did recommend the authors to do something similar, because in the end, they want to make sure that the data collected are available, or segment duration optimization. It would be nice to also, when collecting this kind of data, keeping in mind that longer sentences, if possible, are going to be useful for other purposes. Permissive licensing and metadata stability. These resources were not exactly meant to be used to train models. We did, but there are some legal restrictions in some case, and a bit of back and forth with legal offices. It's mandatory at this point. And we discovered that between some versions, there were a couple of issues. That's something that, of course, should be kept in mind. Metadata should be stable, otherwise they might end up breaking some pipeline. And also asking users if they want to allow AI or machine learning system to be trained on the data in the future. These, of course, are all open issues, because we know that there is some ethical concerns about collecting data for one purpose and then reusing them for a different one, especially given what's going on at the European level. But that's something that we should keep in mind when putting together resources and reusing them. Repurposing dialectological dataset provides an invaluable baseline for low-resource dialectal ASR. That's our case. Corrected ASR outputs contribute to training data, and that's kind of the kind of virtuous circle that I just described. These kind of data sets do help bridging these kind of gaps that I described, and for that reason, they are invaluable resources. And thank you very much, and sorry for being too long.